geology? Geology.
Geology.
Oh yes, geology. Welcome everybody to the Mini Geology radio show, our weekly fix of geology for all the listeners in Houston, in Texas, and around the world. Here we are at KPFT radio station in the heart of Montrose, headquarters of KPFT HD2 channel. This is Daniel Minizini, your inquisitive geologist. And I'm here to talk like every week with the relationship between our beloved science of geology and society at large. Well, we are going to talk today about a blue hole. And I would say that we're not only talking about a specific feature, a geomorphological feature offshore Belize, but we're going to talk about the implications of science meeting the media and vice versa, the media meeting the real science. Exactly 1 year ago, an exceptional oceanographic expedition took place to map with high resolution the Blue Hole, which is a UNESCO World Heritage Site offshore Belize, as I said, and to create a more detailed window into global sea level and climate change over the last 100,000 years. So the program of that expedition was willy-nilly interfered by mainstream media, like the Discovery Channel, and also great sponsors, big names like Virgin. And so today we have a retrospective with one of the main protagonists of that campaign, André Droxler, professor of the Rice University in Houston. André is here with us. How is it going, André?
Good evening. Hello. It's a great pleasure to be here, Daniel.
Yeah, André, how are you today?
I'm feeling great. The weather is absolutely gorgeous here in Houston. A cold front, or let's say a cold front for us, came in a few days ago, and now it's behind. It's nice and sunny and cool. Gorgeous. Gorgeous day.
Are you happy?
Absolutely happy.
Oh,
yes.
Good. So how would you describe yourself, since I didn't really introduce you? How would you describe yourself as a professional?
Well, I'm a marine geologist, oceanographer. I've gone through a regular geology background. First, as you can maybe hear when you hear me speaking, I'm not a native Texas. I did my first geology education in Switzerland, University of Neuchâtel. I was born and raised in Switzerland, and I did my basic training in geology there, which was a very classic training to what we called at that time a diploma, which is about a master's. But I always had some kind of a dream for quite some time during my early years in geology.
What was your dream?
My dream was to become an oceanographer.
Oh my God, you realize your dream.
I did realize my dream, for the past 40 plus years, and it's still continuing. It's kind of odd in a way when you are a Swiss to dream to be an oceanographer.
That's why it was a dream.
It was a dream, yes, yes. I do remember, and I guess I mentioned that to you earlier on. My first time I saw an ocean, which was not even the ocean, it was the Adriatic Sea, and it was the first time I could see a body of water much larger than one of the lakes we had in Switzerland. And guess what? You could not even see on the horizon land. And this was very surprising to me, that you could have something like this. So that was my first time when I saw a fairly large body of water.
How old were you?
I was probably 12 years old. It was a summer camp. They brought in us to see the ocean, to see and the sun coming from Switzerland in Italy. So that was my first time. I really got excited about a big piece of water. I was used to the Lake of Neuchâtel or the Lake of Geneva, which is kind of almost a sin to call it the Lake of Geneva. We call it Lac Clément in Switzerland, to be very local. And yes, in a way, if you're a geologist, and most of the work we did was in the Jura Mountains, Jura for Jurassic for people who are into geology, this is where I learned about my first reefs. These were old reefs. These were Jurassic reefs. So in a way, even though you are not really in the ocean as a geologist, when you go back in time, you go back in time into old oceans. And the Jurassic Ocean at that time, in the area where the Jura Mountains are now, this was a beautiful ocean, blue water like the Bahamas. And so that's really got me excited.
You couldn't see the water at that time.
You could not see the water at that time, but you could imagine it. And you know how imagination is a wonderful part of our human being.
And
we can create anything we want, yes.
Exactly. And talking about imagination, our listeners, through the medium of the radio, they need a lot of imagination. So help the listeners to see this blue hole that is offshore Brazil. How would you describe it with words?
Brazil?
Oh, sorry, offshore Belize.
Belize, yes. There might be some offshore Brazil, but well, it's a very special feature because it's within Lighthouse Reef. Lighthouse Reef is some kind of an atoll, meaning it's a ringed reef enclosing a lagoon. Lighthouse Reef is not a perfectly enclosed lagoon around with a reef, but it is very similar to what you have beside it. We have Glover's Reef, which is a very nice atoll. And so Lighthouse Reef and Glover's are two isolated reefs that are offshore the barrier itself. So it's separated from the barrier, the barrier reef itself by fairly deep basins. So it's very much isolated. And what you would recognize it very fast when you go on a plane or even by satellite, because it's surrounded by very deep water, meaning very dark blue, and suddenly it gets very shallow very quickly. And this lagoon, where it's very shallow very quickly, it's where you have now turquoise water, very light waters. So you recognize this carbonate system, these lagoons, very, very fast, because you have this wonderful contrast between the deep blue surrounding this very nice light blue turquoise waters.
How many of these features exist in that area or around the world?
You mean the lagoons like this or atolls?
And so beautiful like the so-called blue hole that we are talking about.
So the blue hole itself is a very specific feature within this lagoon. So atolls, there are many of them. I've been doing a lot of work, for instance, in the Maldives. And in the Maldives, you have many of them stretch over more than 10 degrees of latitude. So you're looking at a very long stretch. These are, again, ringed reef enclosing a lagoon, a shallow lagoon. It can be 40 meters deep, but often it's much shallower. For instance, the the lagoon itself is only 8 meters. What's very specific and special about the blue hole, it's within the lagoon. So around the Lighthouse Reef, you have this very dark blue. And now in the lagoon, you have this very light blue. And suddenly you see a big kind of circular dark blue area. Very nice circular. So it's dark blue in the middle of this very light blue lagoon. That's made it always very exciting, because the question would be, why does it make it so dark blue? Well, because it's deeper than the lagoon.
How deep is it?
So the hole itself is about 125 meters or 430 feet. And the diameter itself is about 320 meters.
So it's 3-4 times deeper than average?
3-4 times deeper. So it's 125 meters deep and 300 meters wide. But so it's wider than deep, yes.
In the exceptional depth.
Oh, so the lagoon itself is only 8 meters deep. So it's much deeper, yes. So this 125 meters is quite interesting. And we can talk about this. Why is it 125 meters? It's 125 meters is a very significant depth.
Maybe coinciding with some sea level fall.
Exactly. So this dark blue circle that people had seen and had observed from the surface was for the first time visited in 1971 by Jacques Cousteau. And Jacques Cousteau made it very famous because not only he went to visit it, not only he went dive into it, not only dove with regular scuba diving, it's too deep to go really all the way down to 125 meters. So he went down with submarines. He had a few small submarines on his ship, and so in 1971 he went on an expedition, and during this expedition, it also, and most of you might have heard of Jacques Cousteau, but in the 60s and 70s and even probably in the 80s, Jacques Cousteau had created beautiful videos, I would say movies at that time, that were broadcasters all over the world. And he was the first one who brought in the beauty of the world by showing movies on TV, or I think it was mostly on TV.
So this is probably our first contact between doing science and using the media as a megaphone to allow science to be heard.
Probably that was, at least if you think of marine science, this was the case, yes.
What are your thoughts about this connection and the role that Jacques Cousteau had in spreading the word about science?
Well, every time I would mention that I'm a marine geologist, people think I'm a marine biologist, and quite a large number of people would connect marine geologist or mostly biologist, and they would say, because probably of my accent, they would say, "Oh, Jacques Cousteau." So even to this day, Jacques Cousteau is still alive in the mind of people, even though he has passed away for quite some years. But he was the first one to popularize, to bring to everyone the beauty of the ocean and the under-ocean landscape and sceneries. And in doing so, he was able to give people an opportunity to visit these wonderful places, and gave also a sense of the beauty and the environment and the importance of preserving this environment.
Was everything positive what Jacques Cousteau gave to the society?
Absolutely. I think this was the first time finally that someone could bring to the world this beauty and the necessity to keep this environment intact.
I think that Jacques Cousteau was also a very special character because he had both hats of researcher and journalist, if you want.
Yeah, he was really a he was a scientist. I'm not sure if he was a real biologist by training. I don't think so. I think mostly he was, first of all, he was part of the team that developed the scuba diving apparatus, which was a very important aspect, the technology that brought this opportunity to people to go underwater well below our capability of going just with a snorkeling gear. So that was his first impact on discovering the ocean. But now with the Calypso, with this boat, with this ship, he went all over the world to bring to the world, by making movies, this the beauty of this world. So his impact was really
like many other topics and disciplines. It is difficult today in 2019 to have one person alone that masters disciplines so different as developing technology, doing science, and using the video camera for media purposes.
Yeah.
Do you know anybody maybe that is doing that today?
Who do I think of? Barnard?
Or maybe we have more teams today that they cover these different aspects that Jacques Cousteau used to cover by himself.
Yeah, and he did this for many years, yes. It was not just a one-time issue, one-time video, but he did this like a series. So I remember as a kid or as a teenager, the TV would broadcast every week an hour or two of Jacques Cousteau's new adventure. So if at that time I was, and if anyone would be interested to discover and to explore the world, this was a perfect way of doing it, from your own house in Switzerland, for instance. Yes.
Moving forward to the expedition
Yes.
of 1 year ago, we have another Cousteau in that expedition.
Yes, we had Fabian Cousteau, who is the grandson of Jacques Cousteau.
What was his role?
Well, let me maybe go a little bit further to the original expedition.
Of course.
Because what was discovered in this blue hole, even though I would imagine it was already expected, but by going down with submarine and even with scuba diving, if you go down to about 40, 50 meters below modern sea level in the hole, what do you find? You find these amazing cavities, underwater caves with stalactite and stalagmite. And if you really discover stalactite and stalagmite in these cavities, underwater, completely flooded caves, it tells you that no, these stalagmite and stalactite would not have been formed during the time when they will be underwater. They had to be dried up. They had to be exposed. That's the way stalactite and stalagmite now are formed. So I would think that was the first time people realized, or at least at the lines of evidence, that this blue hole was an old cave, or part of an old cave system. And the cave where the blue hole exists today, the ceiling of that cave collapsed at some point and made a sinkhole. Most of the people are familiar with sinkhole on land. So it meant that this cave system occurred when the reef was completely exposed. Sea level had dropped 125 meters. And now this limestone, this carbonate, dissolved, created a system of caves in order to make the sinkhole, the ceiling of the cave collapse. And since the formation of this sinkhole, sea level went up since the last glacial maximum, and now completely reflooded the system. So Cousteau not only went there to do a video and a movie, but he brought with him some scientists. One of them was Bob Dill, and Bob Dill was the marine geologist of that first expedition in 1971, and Bob Dill published several papers. Not only published some papers on this stalactite, doing some isotopes and geochemistry, but also they observed a series of ledges on the wall of the blue hole, some terraces or ledges at different water depth. And they realized that these ledges were old reefs. So these ledges had to be related to different time when sea level was going up. Most likely when sea level was going up, at some point the rise of sea level was not gradual, but it was probably by steps.
Hiccups.
Hiccups. Sea level, and we know much more about this. We know, for instance, that since the last glacial maximum, sea level went up by different steps, and there are two or three major ones. The major one is what we call meltwater pulse, and this is at about 14.5 thousand years ago, and sea level was going up at a rate of about 10 times what we have today, 40 millimeters per year, or several meters per century. And when sea level goes up that quickly, the growth of a reef is not fast enough to keep up with the rate of sea level rise. So you leave behind a reef during this time of meltwater pulse. So you have a series of these terraces within the blue hole, and Bob Dill already published a paper and located these different terraces and identified them. So I'm saying by this, already in 71, they had a very good understanding of the reason why the blue hole existed. It was a sinkhole, and which was reflooded during the last deglaciation, but also that during this deglaciation, sea level had to go up not linearly, but not by big steps, and left behind these different terraces. So it's pretty exciting to think that in the 70s, the scientists related with this expedition already knew a lot about
André,
what you could get out of it.
This story that you told us right now, when you were on board of the research vessel last year, and you had a crew of people in the media asking you these things,
yes,
how much they grasp from what you say, and how much they summarize and synthesize to tell them their way?
Well, I was asked by this expedition to be the marine geologist, and any expedition of that caliber, of that size, need to have a scientific reason to be allowed to go there. And the entire expedition was, at least initially, organized by a company called Aquatica. It's a Canadian company which built submarine. So the owner of the company at some point first made quite some money, was very successful in developing Calgary, and one day went on a diving expedition on his own with a small submarine. And when he was so excited and so enthusiastic about it, he felt, wow, there are very few companies in the world building submarine. So about 5 years ago, he started to build submarine. And this submarine mostly for super yachts. Nowadays, if you have a lot of money, if you have a yacht, not a small yacht, but a big yacht, where you have 1 or 2 helicopters on a yacht, now you also need a small submarine. So the owner of Aquatica decided to build this submarine, and these submarines are not going as deep as you would want to, but they go to 500 feet, which is well enough to go and discover the upper part of the ocean column. Yes, so that's the way they decided to recreate the expedition by Jacques Cousteau in 1971 to most likely do a marketing of their own company and doing science at the same time. And so I was brought in to build up the scientific program in order to get the permit for that expedition. And so the permit was accepted in summer last year, and so the expedition went through it. During the time of the organization of the expedition, it became quite exciting because Richard Branson was fully involved with it. He was going to be diving with Fabian Cousteau. And not only both of them are going to be diving on one of the Aquatica submarine, but also this is going to be broadcasted live on Discovery Channel. So this was the big side of this expedition. Also to do some science. I'm not going to say that this was not a scientific expedition, but the big hurrah or opera was to have Richard Branson there. Fabian Cousteau his name is very well known. I don't know how many people know Fabian Cousteau. I didn't really know him. I'd heard that Fabian Cousteau was a grandson, and I knew his father, at least not by name, but I knew that he was also involved in marine science. And Fabian Cousteau was just a wonderful, wonderful man. And what he does is really promoting the ocean, especially in terms of education. So he has a foundation in New York, as well as Richard Branson. Richard Branson went there to promote one of his foundations, and one of them is in 2030 to try to preserve 30% of the oceans. So both of them were using their name and their name recognition in order to promote their own foundation, which by itself was a great goal. Yes.
So the role of science was a little bit squeezed in between sponsors, owners, and VIPs, and media, because the media present there was also an important media, right?
It was a Discovery Channel, so the Discovery Channel is not any one, and they had even 2 different teams. The Discovery Channel, then the Discovery Channel team, which was ready and prepared to do a live 2-hour program. When we had 2 submarines, we had the red submarine of Aquatica, and we had another submarine. So during these 2 hours, the idea was, or at least the plan, was the 2 submarines to dive together and to have a connection, a cable connection, to broadcast live this dive with Richard Branson and Fabian Cousteau. It turned out to be not possible, mostly because there's always in oceanography, you dream about doing something, and there's always some issues. And in this case, we brought in a fairly large vessel, which was the base vessel where all the broadcasting would be from, and the submarine would go back every night on board. So this was kind of the base vessel. And just to bring this base vessel into this very shallow lagoon, close by, as close as possible to the blue hole, it was not that easy. It was well prepared. They had to in a way scout and find a path for this larger vessel to go. And I was not at the time when they arrived at the blue hole, because we were preparing another expedition ourselves, and I can talk about this kind of later on. But so they prepared a mooring for this rather big vessel to be anchored, and somehow the mooring didn't really was not really adequate for this. Also in December, you have the trade winds. This easterly wind are quite strong, and I don't think they imagine they would be that strong. I don't think they were as stronger than normal. In December, it's often the case that you have this very strong trade winds. And so it took them quite some time to be able to stabilize the base vessel. And they were able to do this not too far, but further away from the whole hedge than expected. So now it was much more difficult not to bring this cable from the submarine into this base vessel to broadcast live. So the alternative was to go and dive the day before several times. So they did several dives with the two submarines and recorded the dives. And so the day of the live program, what they did, they showed some footage of these dives, and at the same time on a base vessel, there will be a series of live interview, describing these dives, and I was part of it. So it was quite an exciting time, just to be live from a base vessel in the middle of this very shallow lagoon, and knowing that, I believe they told me at some point that 30 million people were watching, kind of this broadcast. Yes, in many different countries.
How much time did you have to talk live?
Well, and it's a live program, but it's quite organized. I didn't know this, but these live programs are planned in advance, at least the timing for each of the interview, the timing of how much footage they would show, and for the Discovery Channel, obviously, the timing for all the commercials, because the Discovery Channel is a private entity, I would imagine, and so they raise money by having this program. So when you watch the 2 hours, I was kind of stunned to find out how many commercials you would have had within these 2 hours. And so even doing the live interview, the live program, often we had to wait in order to be able to continue the interview, because the commercial was on. Yes, so it's like American football, or where they kind of stop the game in order to be sure that they would have all that commercial, kind of aired, because that's the way money is made. And the Discovery Channel is a money maker, so that was kind of the when you watch and I think you can still watch it online if you are probably somehow a member of Discovery Channel, but you would be surprised how much time was dedicated to the commercial.
After all, you had how much? Few minutes.
So okay, so Luke was the anchor, wonderful Australian guy, and the few days before, we had a chance to talk, and I was telling him the reason why I was there. So he said, "Oh, you have to be part of it," and so in this well-planned program, I think I had 45 seconds. One question, 45 seconds. And so during the first hour, and I knew where the order was and when I was supposed to come for my 45 seconds. And I could hear around that the producers and the people around would say, "God, we are late. And I'm thinking, oh, my 45 seconds are gone already. And yes, at the end of the first hour, they told me, I said, sorry.
And you didn't talk?
At least not during this first hour. So I was somewhat disappointed, but not that much. I had a chance to be sitting beside Richard Branson and Fabian Cousteau and talk with them during the time of commercials. So,
which was a lot.
So I decided to go downstairs where we could see the broadcast, and there were quite a few people down there.
You quit.
Yes, I thought, okay. I mean, I was not there to be...
What were you thinking to say during those 45 seconds?
It was about sea level. You know, that was it. So...
Tell us in these 45 seconds, what would you have said?
Well...
Ready?
I just said much more than this afterwards. It turned out to be, in life, sometimes one of these disappointments can become an amazing, positive event. So I went down there, and I don't know, maybe in the middle of the second hour, suddenly somebody comes down and says, André, we need to have you. So, impromptu, non-organized, I spent 3 or 4 or 5 minutes, many questions, because somehow they realized that they needed somebody who was familiar with the scientific topics and questions that needed to be addressed. They'd also registered or some interview prior to this, so they would also feed some of these. So at the end, I was in the program longer than I'd expected, so it was good.
It seems that the real goal of the expedition was not exactly science, was not exactly the reach out.
Well, it was science, but not really at a very high level, I would say. One part of the science that the expedition was also to scan the wall in great details and to make a 3D model of the whole. And this was done partially. This was not as successful as perfectly, but there are some wonderful images, 3D images of the edge and the caves and the stalactite and stalagmite. So that was by itself an addition of what we knew, and at least this gave a chance to people to see it. You don't have really to go diving to see the stalactite and stalagmite. So now they're in 3D in a model. And so that was part of the science. And I'm kind of stunned when I ask the questions. First of all, asking a question about the last glacial maximum. How many people know about the last glacial maximum? People understand glaciation. I think most of the people have heard that the climate on Earth has changed quite dramatically in a fairly recent past. But recent past people have great difficulties to find out how far back in time do you have this glaciation. And I should have said glaciations, yes, because there are many of them, and we know now quite well how many of these glaciations have occurred through times. And I'm talking about only during the Quaternary.
But Andrea, how do you know these things? This is while you were talking with a crew on board that you discovered that they don't really grasp what you want to see, or you're talking in society at large? Because
society at large, I would say, and also even within the expedition, the people who had read the scientific program with the scientific objectives that we had, or the reason why we went there in terms of the science, they understood that, yes, 20,000 years ago, I repeat, 20,000 years ago, this is when we had this amazing cold Earth. It was not that colder, but it was cold enough to make these giant ice sheets in North America, for instance. And I always kind of use the example that, whoa, Chicago was under something like 1 kilometer or even a mile of ice 20,000 years ago. I think this touched people much more than to tell them, oh, sea level, in consequence, had dropped 125 meters. I don't think it's even taught at school that sea level could go and drop so much in such so recent time. 20,000 years, at least for you and I as geologists, is just not yesterday. It's a blink of a second in terms of the full evolution of the Earth.
So with this in mind, are you aware that you have to change your jargon completely when you talk with Discovery Channel?
Yes.
And you had the grasp, to do it when you were interviewed. Do you have?
Yes, we were trying not to simplify everything, but just to give this sense of 125 meters. Probably we also mostly used feet because for our American audience, meters don't really mean much. And so if you say, oh, yes, it was something like 430 feet below, in particular in this age when we talk about climate change and we talk about sea level rise, and we'd say, okay, in the next century, sea level might be rising 3 feet. So now if you add on this concept that 20,000 years ago, sea level had dropped 400 plus feet, this become kind of a shock for most of the people. And when you realize that 20,000 years in terms of human lives, in terms of generation, I think we counted once, it's not many, it's maybe 500 generations or 400, 500, 600 generations. So when you put this into perspective, that your great 500 times back would have lived 20,000 years ago. So it's not that much when you think about, and the fact that sea level was so low and these ice sheets existed and covered most of the north part of North America, plus Scandinavia and also kind of offshore Siberia, plus the Antarctic ice sheets had also expanded all the way to the shelf edge. So you have to create all these very large ice sheets in order to, as a consequence, to have this very large drop of sea level. And as a scientist, it didn't happen only once in the last 1 million years. In the last 600,000 years, it happens every 100,000 years. So it happens at least 5 or 6 times to have this dramatic lowering of sea level. But also, what is also very dramatic, it's how fast the melting of these ice sheets can occur. Because after 20,000, about 9,000 years ago, now these ice sheets started to melt. And they melted to the level that now we have sea level where it is. Meaning it melted, so sea level rose about 125 meters in, I would not say it's not even 20,000, because sea level went up almost to today's sea level, even slightly higher, 6,000 years ago. So you're talking about maybe 13,000 years. So in 13,000 years, sea level went up by 120 meters. To me, that's still, for a geoscientist, a marine geologist who have been working on sea level change and fluctuation, this is fast. So you can change the landscape dramatically by doing this. You can reflood all the continental shelves. The continental shelves that we know today, this bordering of very shallow oceans that are, you would say, attached to the land, but are not attached. It's really the flooding part of the continent, or the flooding of this old fluvial plain that existed when sea level was that low. And since the beginning of the melting of these big ice sheets, now these old fluvial plains were completely reflooded and completely covered by the ocean. If we have mostly an audience from Texas, if you think of being in Galveston, you would have to go 100 miles south to find where the coast would have been 20,000 years ago. So that gives you a sense of the reflooding of this fluvial plain, this fairly flat area, can be very dramatic. Imagine in 13,000 years, if you flood 100 miles, 150 kilometers. That's quite dramatic, yes.
Did you have the chance to explain these things to your VIP friend?
I did explain. Well, I explained, when you said the VIP, you think about Richard Branson probably. And so Richard Branson was more interested in hurricane records and tropical cyclone records. I didn't mention this, but this blue hole is also, in addition of being an amazing record of sea level rising by looking at these different ledges or terraces, what really also exciting, at the bottom of the blue hole is partially infilled, not much, but with a very fine silt. And the blue hole, the bottom of the blue hole, is also devoid of oxygen. So it's not very ventilated, a term that we use. It means it's not very much connected to the surface or connected to other caves, which would bring on a regular basis fresh water that would re-oxygenate the base of this hole. So the bottom being anoxic, meaning devoid of oxygen, it means kind of nobody lives there besides some bacteria that don't need oxygen. In this case, and it's really a fabulous record, because when the silt falls and accumulates on the bottom of the blue hole, and because we have no oxygen, it means kind of there's no animals bioturbating, mixing up the sediments. So you have these thin laminated layers that you can find. And because in Belize we are at the latitude where we have a rainy and a dry season, so you have this thin, a few millimeter thick lamina, a white and black and white and black. So the couplet is really record a year, like a tree ring or like a growth band in a corals. So now you have a beautiful calendar. So we were not the first one to take course there, but Eberhard Glacial did this first. I have to correct myself. Eberhard Glacial did some analysis of cores that the USGS took into the blue hole and published a paper. But I had an opportunity to go with Sam Bentley from LSU, and he brought in one of his students at the time, Catherine Denome. It was probably 2010, I believe. So we went there and we took some cores to capture this thick pile of thinly laminated sediments. And based on what Eberhard Glacial had done, we knew that also not only you have these thinly laminated sediments, but also you have layer of coarser material. And you can imagine, if you are now, this blue hole is surrounded by the lagoon. So at the time of major storms, major tropical cyclone, the sediments produced and accumulated in this lagoon is going to be put in suspension during this big high energy storm. Some of this material, well, it's dumped into the bucket, into this blue hole, and create a layer. So when we took this cores, we took cores about 6 meters long, and at the top of this core you can find, thin laminated sediments. You can count the years, and now you have a coarse layer, so you can give, at least you can identify a year, and you would do this in the top of the cores. We would identify maybe 8 or 10 of these layers, and now based on your calendar that you have used by using these thinly laminated sediments, you could give a year. And so Catherine Denome was able to show that 8 out of these 10 layers would be either at the time of one of these tropical cyclones that passed by, or within 1 or 2 years. I think even only 1 year. So we got convinced, and we published this in Nature, so we convinced reviewers that, yes, these layers are very much a great recorder of this unique event. And because now we could go much further deeper in the core, we could go to about 780, meaning we had about 1,300 year record. Now you can find out, and by counting these thinly laminated sediments, plus we did carbon-14 to be sure that we were not off. With this, we were able to show that there are times when we have a frequency of tropical cyclones much higher than others. And one of them was during the Little Ice Age, between about 1400 and about 1800. Surprisingly enough, in particular in the North Atlantic area, the climate went quite cold. As a Swiss, we know this very well, and probably as an Italian, if you have worked in the Alps, glaciers started to grow again, invaded valleys, destroyed villages during that time, and this is very nicely recorded historically. So the Little Ice Age is very well known, but it's also well known in the Caribbean. Sea surface temperature probably decreased by about 2 degrees Celsius during that time, during this Little Ice Age. And amazingly enough, at that time we had only 1 or 2 tropical cyclone per 20 years. On the other hand, if you go slightly back in time between 900 and 1400, this is called the medieval warmth anomaly, and it's the time when the Vikings arrived and even settled down in Greenland. So the climate was quite warmer. It's also very interesting if you are European or if you have gone and visited Europe. If you look at all the medieval towns and cities, maybe not in Italy, but at least in Northern Europe, in Switzerland, all of these big medieval towns are built between 1100 and about 1200, 1300. And it's a time when all the big cathedrals were built in Central and Northern Europe. So it was a time when climate was quite warmer, at least as warm as today. Some people think it was maybe slightly even warmer than today. But I think now the consensus is to say that it was probably about as warm as today. It was a time of abundance. You could have plenty of food. You didn't have to work too much, I guess, on your field. So you have plenty of time and wealth to build this beautiful medieval city. So during that time, in a blue hole, guess what? It's warmer, like today. Well, we had about 6 or 7 tropical cyclones per 20 years. So
and what is the connection, another beautiful, interesting connection with the Maya civilization?
Yeah, so that we are close to the Maya civilization if you go to 900. And so if you go slightly back, the classic period of the Mayan is between 250 CE or AD to abruptly between 800 and 900, most of this urban civilization were abandoned. And so we were very close to it. So in the course we took from the blue hole, we were going down to about 700. And so during this period of time, between 800 and 900, we had very few or no tropical cyclones. Tropical cyclones are obviously very devastating coastline, but they're also a source of rain. So this would have been a period of time when the Mayan would have a lack of rains through tropical cyclones. But on the other hand, also what we did, we took some cores on the shelf, which is, or the lagoon behind the barrier reef, and the Maya Mountains are just close by. The Maya Mountains are this very interesting mountain close by the coast of Belize. The elevation is 1100 meters, and it's made of granite and metamorphic rocks. And during period of high precipitation in this very warm climate, you can do large amount of chemical weathering. And one element that is now put in solution, but not for long, but titanium. Titanium is kind of taken out of these different minerals and put in solution, but it's very not very soluble, so it attaches itself to particulates. These particulates are going on to be transported by rivers, and these particulates are accumulating on a shelf. And on the shelf, on this lagoon behind the barrier, there's a series of beautiful mini atoll-like called the rhomboid reefs, so this ringed reef enclosing a lagoon. And so we took cores in the lagoon, which is not anoxic, but it's very protected. So we took these cores, and through different types of analysis, and now you can scan by XRF, you can scan the surface of the core when you cut it, and you count elements. So through XRF, you can find out what will be the different counts or the variation of different counts within the core. At that time, I was more interested in elements that are related to calcium carbonate, like calcium, strontium, magnesium, and not really much of anything else, because I'm a carbonate sedimentologist. But in doing the scan, you scan for many other elements, and at some point, by curiosity, we decided to plot other elements, and I knew that titanium was kind of an exciting element because it was what we call a proxy for precipitation inland. And some work that we had done already in different places, like in the Caraco Basin, and people have used titanium as a proxy for precipitation. So when you have a lot of titanium on this shelf, it means kind of you have good precipitation inland. When you have low titanium, it would be a time of droughts. Guess what? So when we plotted this titanium in our cores from the shelf, we realized that we had one interval which had very low titanium or no titanium. And when we, by carbon-14, dated this interval was between 800 and 900, which gave another line of evidence that the century, when this urban civilization, very successful urban civilization of the Mayan, which had reached a peak, and now we think there were not hundreds of thousands of people living in the Yucatan Peninsula, but there would be millions. At that time, suddenly, they didn't destroy no kind of their urban cities, but they abandoned them. And we know that they are extremely dependent on rain. Even their entire religion is based, not entire, but a large part of their religion was the god of the rain, because as it is today, the Yucatan Peninsula, as I mentioned already, lives in this mode of rainy and dry season. When the ITCZ, the Intertropical Convergence Zone, moves north during our summer to the latitude of 23.5, or the tropics of Cancer. Sorry, I had Capricorn in my head because I was in Sao Paulo just last week, and I know Sao Paulo is exactly on the 23.5 on the tropic of the Capricorn. So thanks for your patience, the Cancer. So when it moves up there, and Belize is 17 degrees north, yes. So now when the ITCZ moves to the tropics, it brings with it this zone of rain. So it's a rainy season during the summer. And the Mayan did very well because they knew this, that after the rainy season, they would have this period of droughts for 3 or 4 or 5 months. So what did they do? They would build large reservoirs, and there's still a lot of signs of these big reservoirs. They would even, the pavement they would have on this big plaza, they would cover them with chalks in order to be sure that they will be impermeable, and they would drain all this water into these big reservoirs to be able to last through the dry season. And archaeologists have estimated that they had reservoirs, enough water for at least 2 years after they would fill up the reservoir. So they could last for 2 years if the rain would not show up.
André, your connections from geology to society and the curiosity of society at large are superb.
Well, it is very exciting. At that time scale, when you start about geology at our time scale where we have civilization, we realize very quickly that civilization on Earth have thrived, often, if not always, because of favorable climate, and they have collapsed because of unfavorable climate.
And actually is also easier for geoscientists studying these ages to connect their basic scientific studies to something interesting to society, especially to history or prehistory, and that would bring up their topic, let emerge the topic, because it's naturally connected with things that are curious to humans. What about when we study basic science that goes back in deep time? How many of these connections between media and science do we need? So based on your experience, the experience that you had in your career, and maybe the last one you had in the expedition of the Blue Hole, what would you suggest to researchers, professors, professionals that they are studying basic science or applied science? How much they should dedicate, how much time they should dedicate, how much effort to look for these connections with the media?
I think we had a lack of communication for many decades, at least in my 40 years of being a scientist, a marine geologist. We didn't take, at least in the first 20 years, much time to communicate our science at another level than just our scientific publication. In the past 20 years, NSF, the National Science Foundation, has realized that this was very important to bring our scientific results to everyone, so not to kind of stay in our tower and just keep doing science just for ourselves, but we have to show the importance of our results or of our scientific endeavor and research to the people who usually fund this research. But not only this, to kind of get them connected to processes like in geoscience. Yes. So I think we are doing much better now. But there are a few examples that I can promote geoscience, and I am myself one of these examples. And I was probably lucky, or it was maybe not just luck, it just happened. But I gave a short presentation at AGU, the American Geophysical Union meeting in 2014 on this Mayan connection. And you have been at AGU. If you go to an AGU meeting, there are 25,000 people. There are many sessions in parallel. You have 12 minutes to talk. And I gave my little talk in 12 minutes. And you have one question, and you say, okay, this is it. My communication is over. And this woman comes in, and she's from Life Science in New York. And she's the one who took the results and promoted it to the media. And this became a huge deal. So if you can find, first, is your topic of your research. But any topics of research can be somehow given a spin where this can be much more exciting and be communicated to the large public.
Thank you, André. We were in conversation with André Droxler. André, amazing how the time flies when we talk, huh?
I know. I thought that we had only been here for 20 minutes, and now it's about an hour. And I have many other things to talk about, and you can always invite me to come back.
What do you want to talk about next time?
Well, maybe we can talk about microbial reefs in Central Texas.
All right. So
and not only microbial reef, but they are 500 million year old. Imagine.
All right. So we'll dive from 25,000 years ago to 500 million.
Yes. That's the beauty of being a geologist. You can not only live today, but you can go back in the past in order to understand what the future is going to look like. That's the beauty of geologists.
And with these wise words, we say goodbye. This was a mini geology show, this time with Professor André Droxler from Rice University. Thank you, everybody. This was mini geology.
Goodbye.